In this video, we're going to talk about a situation in capital budgeting where we have two options for a project. The differences between the project can kind of be narrowed down to quality, right? We can do something cheap, obviously less expensive to purchase, might be a little bit more expensive to manage, right, to run. But because it's cheaper, it probably has a shorter lifespan. The other project will cost more, probably be better quality, so it might be easier to maintain, but at the very least, it's going to have a longer lifespan. So in this example, we have two projects. The project A has a net present value of $40,000. It has an expected lifespan of 2 years. And the discount rate on these two projects, they're essentially the same projects, is 10%. This should say Project B over here, but Project B costs $90,000, has a lifespan of 4 years, and again, the same discount rate. So the first technique that we have is to try to find a way to annualize this net present value. Let's convert this lump sum present value at the beginning. What would that be in a time value sense if we could convert that to payments? So asset A, if we convert that, that would be $23,000 each year. So roughly we get $23,000 a year from the present value if we do project A. If you do project B, you get $28,000 a year. Now, this isn't that you get it, we're just converting this lump sum into a series of payments for the life of the asset. And of course, here you can see that the annualized net present value is greater for project B than it is for project A. Another technique is what's referred to as the replacement chain technique. Essentially, what it does is says, look, we need to repeat these projects until they have an equal or a similar time frame. So if we do asset A twice, right, that means it's going to last for 4 years. But it's kind of difficult to program that. So what I do is I just convert these and multiply them. You take this number times this number, means we're going to repeat this project 8 times. Then we're going to find the net present value from that series of investments. So let's go over here. We'll slide over a little bit. We can see how this works. So here's project A. We're going to have to do it 8 times. Now the net present value is calculated today. So we're going to calculate this net present value 4 times. You can see that here. 1, 2, 3, 4 times. Now we need to find the present value of each one of those back to today. You can see it's just a time value calculation. Just a time value calculation. And then at the bottom, scroll down here, we sum that up. So project A, if we do it, in this case, 8 times, right? We're going to end up with $122,000 is what we refer to as the replacement chain. If you do the same thing with project B, now project B, right, it's 4 years, so we're only going to do it 8 years again, but that means we only do it twice. That net present value, when you add that together again, gives us this 151. So again, if we look back at this analysis, it tells us that project B is a better project than project A. Now, This doesn't work this way all the time. This is just the way these numbers work. There will be times where even though project A has a lower net present value, there are times when it will have a greater annualized net present value than project B. It's just the way the numbers work. So you select the project that has either the greatest annualized net present value or the greatest replacement chain. And I would also think, based on the way the math works, that these two techniques will always agree with each other. Right? They'll always place them in the same order as far as which one you should do and which one you should not do. So again, that's the unequalized capital budget project analysis. Look forward to seeing you in the next video.